Hey everyone, welcome back, and in this video let's just understand why hooks were needed in the first place. Well, you see in React there are mainly two ways to create components. The first one is class-based components and the second one is functional components. For a very long time since React was launched, the statefulness, that is, your component could hold internal state only with class-based components. And the way you create a class-based component is you say class button, extends react.component, and then you do all that stuff. With render, you return something, and that will be your class-based component, right? You can also add state in here inside your constructor function and do all sorts of stuff. However, this was never possible with functional components before hooks. So hooks enable, in very simple way, hooks enable you to have stateful components inside, stateful paths inside your functional components. How? We're going to be seeing that with a variety of hooks, useState, useEffect, useLayoutEffect, all that stuff. But the main hooks, the major two hooks, you have to understand very deeply, and something which you would be using all the time are useState and useEffect. And we're going to be starting off with both of them. Starting off firstly with useState from the next video onwards. So that is all for this one. I'm going to see you in the next video very soon. Hey everyone, welcome back. And in this video, let's just go ahead and take a look at useState hook. So first things first, I'm just going to go ahead and switch this to browser so that we have more space for the browser. And next, I'm going to show you how you can create a useState hook. So what you want to do is, first of all, you can just go ahead as an exercise, we can just go ahead and say console log useState and let's say 100 as the value. And what you have to do first is bring in this useState from the React library. So you can do that simply using this. And once you do that, you're going to see that if I open this in a new window, if I inspect this inside console, we're going to be seeing that, well, we have a console, we have a couple of consoles actually, and this says 0 as the 100 value and 1 as the function. So what does that mean? That means that this returns an array, number one, that is our observation. And the second observation is that this array right here, if I try to do console log array, you're going to see that this array right here would consist of the first value as the value which is passed here already, and the second value is a function. So now you can go ahead and destructure it into something like const state is equal to array 0 and const set state is equal to array 1, right? And just to keep syntax smaller and much cleaner, the convention is to just destruct it right here. So you can do that because of the ES6 syntax. So this just means that useState returns an array with two values. That is, the first one is state, which is exactly what you passed here. There are, this is not entirely true, so we're going to understand that later on. But the state is exactly what you passed here. You can assume that for now. And the second value is a function which can help you update the state value. Now, one thing very important you can see here is that I declare the statement as const. That means both the state and set state values are going to be constants. That means you cannot assign them a value by equal to sign. What do I mean by that? If I go ahead, first of all, let me just go ahead and give it an h1 of state like this. So now if I do that, refresh this right here, we will be able to see that we have 100 on the screen. What I cannot do is if I want to change this, for example, if I do on click, something like this, I cannot say state is equal to 200, right? Why? Well, I could say that, but if I go to refresh this and if I click on this in console, you're going to see we get an assignment to constant variable error, right? Now you might argue that this is obviously because I'm using const. So even if you use let here just to, allow this to happen. Still, if I click on this, you're gonna see that although the value has been assigned, you can just do console.log state here, value has been assigned. What you're gonna see is that this value is not updated on the screen. Why? Because React does not know that you have changed the state variable. This is a regular variable. React is not monitoring this variable or anything, right? So when you update it, React does not know that, hey, you have changed the value. The way you inform React about that update is that you call this setState function, right? Now, this could have been like one way that you update the state and then you call it. But what React does instead is that it asks you to pass this value, this updated value, the value which you want to set inside the setState function call, right? So just like inside useState, you pass in a default value, you can pass in a default value. Similarly, when you set a state, you have to pass a value which should be a new state, right? So in this case, if I pass 200, and let me just go ahead and remove this for now. We're going to be coming to that later on. So if I pass this as 200, you're going to see if I go ahead and refresh this, if I click on this, now it changes to 200 on the screen as well, right? Now, the reason I removed this console log statement is because I will be discussing the exact workflow of how the state updates and everything later down the video. But for now, that's all you can remember, that if you want to update the state, you're going to make use of the setState function. So yeah, that's pretty much it for this video, this small introduction video. I'm going to see you in the next one. We're going to be moving more into useState hook and different ways to initialize variables. Hey everyone, welcome back. And in this video, let's just go ahead and understand a very important concept, and that is lazily initializing state in React. Now, what you can see, I told you that you can go ahead and pass a default value inside this, but there's a catch. The catch is that this value can be anything or a function. So I have divided this value which we pass into two things, anything else and something which is a function, right? So if you pass in a function here, for example, function like this, or if you want an arrow function, lambda function like this, or maybe this could be a separate function all along, you know, const lazy value, something like this. This is also fine. And you can pass in lazy value like this. So whenever you pass in a function, what React will do, that will check that, hey, if this is a function, I'm going to call this, and the value it returns, I'm going to set that value as the initial value of stuff, right? So if I go ahead and return this 100 right here, refresh the terminal, you're going to see that we get a state of 100. Well, on clicking, it becomes 200. If I return, let's say, hello right here, refresh, you're going to see that we get a state of hello. Now, why would you do something like this and not directly hello like this? Well, it would work. Obviously, it will work just fine like this as well. And this is absolutely fine. You do this if you have a singular expression which is, let's say, computationally expensive. For example, you do a JSON.stringify of, not really stringify, but maybe like parse of something like this. Now, this is also completely fine. I mean, there's nothing wrong with this as such. But the only problem with this is that every time the state changes, this function gets executed. Why? Because this is inside running code. It has to evaluate it anyway. Because when this useState function was written, it might be written in this way. That useState, react.useState is something like this, initial value, right? So the authors might have written this in something like, if type of initial value is equal to a function, then call it, right? And do something with it. And if it is not, then maybe just do something with initial value. In either case, if you do a json.parse of something like this, so when the type of this is being evaluated, the function call has already been made. That means this would be made over and over and over and over again, because if this is a function and first time, this is an important part, that if this is a function and if this is first time, then we evaluate it, otherwise we ignore it. Or maybe like, if this is not the first time, we would ignore the value. But if you have a constant expression, which is actually a call to a function in itself, then it is a problem. Let's take a look at a very simple example to understand that. I'm going to go ahead and do a console log of hello world here, right? And that's it. And right here inside set state, let's just set the state to math.random so that we get a trigger, a re-render on every click. Let's go ahead and refresh this tab, which is again pretty much the same thing which has already been opened. And you see that we already get 2 hello worlds here, right? We already get 2 hello worlds. If I start clicking on this, you're going to see that we get more and more hello worlds. Although this value ideally should be the initial value of the useState hook, still we get all these hello worlds because React would anyway call this function again and again whenever the render happens. We're going to be coming to that in a moment in some other video. But what you have to understand is that whenever you call a set state function or set something function, which is a useState second argument, you trigger a re-render of state, a re-render of the function, given that the state is different, right? Because if I set this to 200, for example, and if I go back, refresh this, if I click on this, we get a trigger first time, and then when I keep clicking on this, nothing happens, right? So that is why I needed math.random here, so that I can trigger multiple updates and then we will get multiple console logs. In this case, we do not get any more console logs because, well, the state is not updating. So React does not re-render the function. What you have to realize here is that if I try and put this console log in a lazy initializer, then if I refresh this, you're going to see that this happens only for the first 2 times. And now if I click on this, this never happens again. And this happens for 2 times because, well, it re-renders again because of the React strict mode. Because in strict mode, React tries to render your component again just to see if there are any side effects so that it can inform you. We'll discuss this more in the advanced React patterns course. But for now, if you remove strict mode out of it, refresh it, you're going to see your component is rendered only once, which is helpful because we don't really want to bother working with twice the amount of logs. So anyway, now you could see that if I click on this, well, if I change this to math.random, and if I go ahead, refresh and click on this, nothing really happens, right? We don't really get any more console logs. And the reason for that is that your state is lazily initialized, because now it just sees the next time when the component re-renders, it sees that, well, this is a function which is passed. Therefore, I don't need to re-render, or maybe like I don't need to call this function at all because I already have the stored value from the function itself. So that is why it will not call the function again. But this means that inside useState, you cannot really store a function, right? Because, well, if you store a function, it will execute it. And if you try to store a function, it will execute it, and then you will lose the results, right? So there are ways to store this, and that is you can have a function which returns a function. So what React will do is that it will call this function, and when you call a function which returns a function, you get a function. Now this might seem a little weird, but if you do hit this enter, you can see you get the inner function because you called the outer function. And that is exactly what React will do, and then it will store this value, which happens to be a function, inside your useState hook. So that is all for how you're going to initialize the useState lazily. And in the next videos, we're going to be learning more about useState how they exactly work, and how to work with other hooks in React. Hey everyone, welcome back. And in this video, let's just go ahead and take a look at how you can update your state variable. So let's say we start this as a counter application. Why not? So we have a counter, set counter, very simple stuff. And inside h1, whenever I click, counter is, let's say this is a counter. So whenever I click, I want to update this counter, right? So one way I could do is that, just like we saw, that set state accepts, anything you want, and that will be the new state, right? Or set counter in this case. So once we do that, once I refresh this, you're gonna see whenever I click on this, this counter works absolutely fine, right? And obviously you would expect it to work as well. However, what else you can do with the setCounter function is that you can specify the argument instead of a value as a function, right? So what is going to happen is that now if I have, let's say, instead of creating a function out of the thing, we can also pass it a function like this. So now if I return it a value that is, let's say, 50, React, just like it does with the lazy initialization function, it will also do the same thing with the setCounter function, or maybe like setState function, whatever you want to call it. So if it sees a function is passed inside the setter, it will execute this function, it will get the value which is returned, and then it will set this. Now you might ask me that what is the use case of this? So first of all, let's just click it and verify that yes, in fact, this is 50 now, and it is not changing whenever I'm clicking on that. The use case of this is that this function right here, the first argument, is going to be the value which the React internally knows is the value of this, it's the counterpart of this setter function. That means the first value, if I go ahead and put value here, and if I put value +1, this value right here is the value of the counter itself. And let me just go ahead and refresh and tell you why that is the reason. So now if I click on this, you could pretty much see that this works similar to how count +1 worked, right? Now, you might ask me that, hey, or like not really count, but counter +1. You might ask me that, hey, why do we need that anyway, right? Because you already have access to counter, you already have access to the updated state. So why would you need that? Well, the reason for this, and there's a very good reason for this. First of all, this will help you very much with the useEffect hook, which we'll cover very soon in the next few videos. And second of all, at the moment, I would request you to just keep this thing as a thought in mind that whenever your state, your next state, that is the updated state, depends on previous state, that means you need your previous state to calculate the next state. Whenever that is the case, use the functional method, right? Return counter +1. Now you can have this as value, doesn't really matter, because this function right here would be called by React internally, right? So internally what React would do is say set counter, and if it sees a function like this might be the definition of the React set counter function. It will see that, hey, this is if type of value is a function. It will say, then go ahead and execute value with the newest state value, right? And then, return value as the newest state value, and then it will just set that as the new value. But what I'm saying is that, in this case, you can see that, well, because we are creating a counter which increments, it depends on the next state, right? So you need 14, you need 13 to create 14, you need 14 to create 15 because that is the next value, right? So in this case, you need it. Therefore, make use of the functional notation. If you don't need it, if the previous state does not depend on the next state, then you can just go ahead and directly set it. So for example, if I refresh this now, this would work just fine because, well, the next state is completely random and it does not depend on previous state. If you want to do something like this, that is also completely fine, but this is not required, right? And I'm going to show you an example maybe in the next video why this is a good approach if your next state depends on the previous state. So this is like one way of updating values in React, and you should understand that when you should use it whenever your previous state depends, whenever your next state depends on your previous state. That is the ground rule. So yeah, that's pretty much it for this video. In the next one, I'm going to show you an example of when this will be helpful and when this will fail. Hey everyone, welcome back. And in this video, let's just go ahead and take a look at when exactly the set counter will not work and when will you need this approach. Now, almost always, if you do not know what you're trying to do, just like I said in the last video, the rule of thumb is that if your next state depends on your previous state, you almost always want to do this approach, right? Let's see why. First example is I'm going to create a set timeout here, right? Just to introduce some delay. So I'm going to say after 1 second, whenever I click on this, then do a set counter of counter +1, right? So now if I go ahead and click on this, you're going to see that after 1 second, it updates the value, right? Let's just go ahead and copy this out and paste it right here. So now when you think about this, what do you see? Well, you see that, first of all, let's just go ahead and update the counter. So in your case, if I refresh this, the counter will go from 0 to 1. And here you might think that, hey, I want to increment the counter again. So it should go from 1 to 2, right? Wrong. Let's just go ahead and click on this. So it goes to 1, but it never goes to 2. Why is that? And as a matter of fact, if you do a, let's say 500 here, then also you would expect this will go to 0 to 1, then this will go to 1 to 2, and then this will make it go to 2 to 3, right? Wrong. Let's refresh this again. Click on this and you're going to see the counter always stays on 1. Now to understand this, you have to understand how React functional components work. Well, in React, just like I told you in the first few videos, I'm not going to give you an in-depth look of how the function re-renders. That is going to happen in Advanced React Pattern course, so wait for that. But in this video, I'm just going to give you a brief overview of how this happens. So what React sees is that whenever you call setCounter as a function, it sees that, hey, there is a state update. It will internally compare if there's any change in the state, and if there is, or if it feels like re-rendering, it will re-render the component, right? However, what do you mean by re-rendering the component? Re-rendering the component means calling this function, right? So what's happening really is that your UI is calculated every time. For example, the app component has changed, so we're going to call this app component. React is going to do that internally, and your UI is created, and you can think of, React says to browser, go paint this UI, right? This is your UI thing. So React does this particular stuff. Now, when you do something like this, what is happening is that inside a particular function call, when this function was called for the first time, this function had the counter value as 0, right? Because that was the initial state. Then when somebody clicked on this, you read this counter, which is still 0, and you set this to 2, or 0 plus 1, that is 1. However, after 500 milliseconds, you are still reading the same counter, right? So, you're still doing 0 plus 1. You're not doing 1 plus 1. Even though you might think that counter is a state variable and I have already set counter to 1, this 1 right here becomes counter only when React calls your app function again. Remember that your UI is calculated only when React calls your app function, right? So when you call setCounter, it updates it to 1. This value is not counter of the current function. This is super duper important thing to understand deeply how the useState hook works. Why this 1 is not a value? Well, for starters, you can think of, because you cannot really assign counter as 1 because it's const. That is why I prefer to keep hook values as const, because they convey the meaning that this is immutable. That is, neither React nor you would change this value, right? So once you understand that, once you realize that this set timeout runs with the same counter variable, you get that, right? Because you know that this variable, this value is not changed. This is still 0. So you have 0 plus 1, 0 plus 1, 0 plus 1 all the way here, right? Now, let's come to functional sort of update inside the set counter variables or the set counter functions. So instead of this, let's just go ahead and do a counter plus 1, right? And see that I'm still using the local variable. So obviously you should now, by the time you should now have realized that this is no different than the previous code snippet which we had, right? Well, I clicked on that twice, that's why it happened. So let's just go ahead and click on it only once, right? So you can see nothing really happens. And the reason nothing really happens is because you're still using that old stale value, which has now been flushed out. So how do you fix that? Well, you supply, or maybe just like I said, use the updated value right here. Now, whenever React is calling this function for you, whenever React calls this function on your behalf, we have seen that React will see that if this is a function, it will call it with the newest state value, because React internally knows what is the latest state value, right? So React knows that, well, whenever it has to call this to update the new value, update the new state, React will automatically specify the latest value of state. So if I go ahead and refresh this now, and if I click it on it once, you can see that it changes to 3. And the reason for that, just like I said, the first time it changes to 0 to 1, the second time it changes to 1 to 2, and the third time it changes from 2 to 3, right? So you can see right here is the transition. And the reason this works completely fine is because every time this function right here, you can extract this function and say this update value like this, and you can go ahead and probably give it something like this. This is also fine. The reason this would work, just like I said, is because React knows what to put in here. React knows that, hey, the latest value will go automatically inside that particular argument. So yeah, that's as simple as that. I hope you understood how the functional update in a useState hook works. Super important stuff. And the only thing you can take away from this one is that whenever your previous state depends on your next state, I always speak that in a wrong direction. Whenever your next state depends on your previous state, you should use this particular approach, right? Because this will help you not to get those troubles of using a stale value of state. If you have timers, or if you're somehow jumping out of the reactive way of doing things. So yeah, that's pretty much it for this one, and I'm going to see you in the next video. Hey everyone, welcome back. And in this video, let's just go ahead and take a look at how we can recreate the this.setState from class-based components. So let me just go ahead and clean this up real quick. And what I'm going to do is I'm going to tell you a little bit about what this.setState was, right? So if you had a class-based component like button extends react.component, so if you had something like this, what you could do is if you have, let's say, div id counter, something like this, or maybe like not counter, but this.state.counter, and inside constructor, if you have this.state as counter as 0, and then what you could do is on click, you only had to specify the variables you want to update, right? So you're going to say this.setState is counter is this.state.counter plus 1, right? So that's it. That means that if you had a counter 2 right here, and if you had a this.state.counter2, this will not affect the state call, the state update will not affect the counter 2. So let's just go ahead and see if I just go ahead and embed this button right here, which already brings in its state. So if I go ahead and do that, you're going to see that, well, we are lacking a super call here. So once we do that, you can see now we have two numbers, and we could change this to h1 for a little bit more readability. So now we have two numbers. So when I click on this, you know, the second counter works just fine, right? So if I have counter as 10, this would work just fine. So if I have the first counter would work absolutely fine. But if I try to recreate the same example in functional components, what we're going to have is state, set state, and I'm going to have, you know, counter 0, counter 2, 10, right? Similar stuff. This.state is useState here. Then what I want to do is I want to have the same thing. So I'm going to go ahead and comment this, basically the whole thing. And I'm going to have a return of this thing right here. And instead of this.setState, I'm just going to say setState. And I'm just going to say state.counter plus 1. And this will also become state.counter and state.counter2, right? So now you can see so far it looks fine because, you know, you just have a single thing and a 0 and a 10, just like we had in class-based components. But the moment you click on this, you can see that the 10 vanished. And the reason the 10 vanished is because this setState call right here, it overrode this counter2 property. Why? Because you know that whatever you supply inside setState would automatically be set as the new state. So on the first render of this app function, your state is counter 0, counter 2, 10, right? So this is your first render state. Your second render state, once the button is clicked, the second render looks something like this. The counter 2 has been removed from this. So how do you reconstruct this behavior where you can just simply go ahead and supply something like this? Well, you can do that, but you have to be a little bit more clever for that. So instead of having set state directly out of this, what you can do is you can create a function which is, you know, just an internal use function. And then you can have a function set state, which would say receive new state right here. And what this will do is that this will set state, it will call the internal set state, old state, and you can return a new object, which is the combination of old state and new state right here. So let's take a moment to see what's happening here. So what we are doing is that we are specifying set state, which is this function which we are now calling, as another function altogether. This is not your second argument which comes with useState, right? This is another function. So this function right here accepts a new state, which is object in our case, and it calls the internal setState function. However, it takes in the the previous sort of state, which is the newest state, and it returns a new object. And the reason we did this and not just something like state and new state is, I hope you remember from the last video when I said you that whenever you want the next state, whenever the next state depends on the previous state, you should probably, it's a good idea to use the functional notation of updating stuff. So we do that, and we destruct the old state, we destruct the new state, we destruct the new state after the old state so that the properties are overwritten, whatever properties are changed, right? And yep, that's pretty much it. So now once you have done that, you can go ahead and refresh, click on this, and you're going to see that 10 basically stays just like it will stay in a class-based component. So yeah, that's pretty much it. And how you're going to recreate this state and setState, you could pretty much now go ahead and basically throw anything in the state variable, and you can just call setState with a limited number of things which you want to update, and it will work just fine. But of course, I would not really recommend going down this way unless you know what you're doing, because just like I said, you can have multiple useState in a single function, right? This is probably a better idea if these are not like a lot of things to have a separate useState, right? So you can have set counter as useState 0, and then you can have counter 2, set counter 2 as useState 1, or whatever you want. And then you can just maybe just update a single hook if you want. But again, it also has its use case. The other syntax also has its use case. So it really depends on what you want to do. But this is like one way, one analogy if you're somebody who has done a lot of stuff in class-based components. So yeah, that's pretty much it for this video. I hope you understood something new, something good. And that is all for this one. I'm going to see you in the next video really soon. Hey everyone, welcome back. And in this video, let's just go ahead and move on to useEffect. Now, useEffect is one of the two most important hooks, I would say, in React. And those are like useState and useEffect, right? So useEffect allows your component to be aware about changes. So what do I mean by that? Whenever you update the state, for example, let's just go ahead and remove this all along and create a counter, set counter again. So we can have something like return h1 counter, right? So this should also be inside the app class so that we just have some CSS with us. So once you do this, what you have to realize is that whenever the counter updates, for example, if I on click and set this, set counter as counter +1. So whenever you do something like this, what you have to realize is that your component gets updated, right? But how do you know the component is updated? Or maybe like if you want to do something whenever the component updates, how do you inject into that lifecycle? You do that with the help of useEffect hook. Now this hook right here consists of two parts. The first part is a function, right? And the second part is a dependency array, which is optional. So I'm going to remove the dependency array at the moment, and we're going to just focus on this function. Now, what I'm going to do is I'm going to go ahead and console log something changed, right? And that's it. That's all I'm going to say. If I go ahead and open this in a new tab now, go to the console, you're going to see we get something changed, even though nothing really changed. So if I click on this, if I start clicking on this, you can see that I get something change exactly one time more than our counter, because our counter starts at 0 and we already had something change already available. So if I click on this, you can see that we have something changed on every single state update. So I can go ahead and say counter1 as this, and I can go ahead and say counter2, for example, if I want to create another counter as this, and I can have, let's say, counter2, set counter2, and this could be just counter2, or maybe like, set counter2 only, because we are not using, we are using the functional notation, so that's convenient. So now if I go ahead and refresh this, if I start clicking on this one, you're going to see that we still get something changed console logged. And if I click on this, we still get something changed console log. So this means that if you do not provide a dependency array, that is the second argument, this will always run whenever your component updates. And when exactly does it run? We're going to see that in the life cycle sort of video, which will happen very soon. But what you have to realize is that whenever you use useEffect without a dependency array, it will always run whenever this function re-renders. This is something which you almost never really want, because you want an effect to run against a particular value which is changed, right? You don't really want to monitor, like, unless you're trying to debug something, or you're doing something or checking how many times the component re-renders. You just want to focus on a single or maybe like multiple values, not really like every single update. So we're going to be taking a look at how do you restrict it using dependency array, what exactly that is, and how this works, how that works in the next video. But in this video, I just want you to realize that the useEffect is a function which runs by React, which is, React calls this useEffect function every time the function is re-rendered or updated, or, React calls this function again. So yeah, that's pretty much it for this video. I'm going to see you in the next one really soon. Hey everyone, welcome back. And in this video, let's just go ahead and take a look at the dependency array in the useEffect hook. Now, what do I mean by that? That means that you can specify an array as the second value. Now, it has to be an array or it has to be undefined, nothing else. But if you specify an array, that means that you say React that, hey, look, I don't really want to render, I don't really want to call this function on every single render. What you can do is go ahead and look inside this array and check the values which I have specified. If those values have changed, then and only then run this function. So you see what you're trying to do here is that you are binding this particular effect to a set of values. So you're just monitoring these bunch of values, whatever you specify in here. And yep, that's it. If those values change, you read in the function, you call this function again. If they do not, you don't call them. Let's see. So if I go ahead and specify counter here, and if I say something changed, or maybe like just say counter1 changed, let's do that and go to this new tab, refresh right here, and see that the first update which you get is counter1 changed, even though that is not changed. So with useEffect, what you have to remember, the first time your component is mounted successfully, a useEffect call is run, right? It doesn't matter what you specify inside the dependency array, the first useEffect call will always run whenever your component is mounted, right? Now, once that is mounted, now you can go ahead and change counter1 by clicking on it. And you can see every time you do that, the counter is in fact updating, right? However, here's the cool stuff. If I update counter2, you can see that this counter1 changed does not appear, right? And the reason for that is that, well, whenever you click on this, sure, the counter2 updates and the whole component is re-rendered. However, your useEffect is not configured to run the function on counter2 changes, because you do not have counter2 inside dependency array. Now, if you go ahead and add counter2 here, now you can say counter1 or 2 changed like that. And now if you refresh, you're going to see that you get counter1 or 2 changed console log on this one, and counter1 or 2 changed console log on this one as well. So you can see it happens for both the counters. Similarly, if you get rid of this at all, you have to change this to something, right? And the reason for that is because not only it will re-render and run this particular thing on counter1 and counter2, but also if say you receive new props from the parent or the parent re-renders, right? So in that case also this will render. So it will say something changed, so it will work just fine. Again, just like you can have multiple use states in a component, you can have multiple use effects. So you can have like counter1 changed, and you can have counter2 changed like this, right? So maybe you can do some logic here for counter2 only, you can do some logic here for counter1 only, right? Whatever you want to do it. So once you do that, hit refresh, you can go ahead and see now, right now you just get counter1 changed, now you just get counter2 changed, and so on and so forth, right? There's one little thing you should remember here is that if you try to update your state inside useEffect, you might run into troubles, right? Because you see, if I go ahead and do set counter of counter plus 1, you see what's happening here is that you have created an infinite condition, right? So you see it keeps on updating all the way till whatever it can support. And yeah, it is not exactly it's not exactly rushing to infinity or anything, because it has to do a lot of stuff, but you start seeing these sort of error messages that, oh boy, slow down, stuff like that. So you almost always don't really want to get into a condition like this. So don't really try to update. I mean, again, if you know what you're doing, it's completely fine. But as a general rule of thumb, if you see yourself updating the value of the state variable without any if-else checks, you might want to revisit your logic, right? So yeah, that's one thing about the dependency array. Another thing which is important about dependency arrays is that these values right here are compared using triple equal to sign, right? Inside the React library. This is super important because now you cannot really use objects right here. So for example, let's say you have an object which is hello1, right? You see, you're not changing this object, nothing is happening, and you just have a single, let's say, counter and an object dependency, and you say console.log counter1 updated, right? Which makes sense because you could see that counter is a state variable which you're monitoring. An object is a simple object which just has hello1 property. However, if I go ahead and open this in a new tab, if I inspect this, go to console, if I click on this, we get counter1 updated, which is completely fine. But if you click on counter2, you will see that you get counter2 updated as counter1 updated as well. At the same time, you can observe that counter1 was never updated. Then why it is happening? Why is it happening? Well, you see that in the last video we discussed briefly on how React really works with functional component. That is, it calls your functional component again and renders the stuff with the updated state values. But here, when it calls your function again, you're gonna see that objects in JavaScript are never the same. That means even if they have similar values, you're gonna see they return you false. This is false because this object right here if you have x as the variable, this object right here in the memory is represented somewhere else, right? And y is represented somewhere else as well. So if you think about it, x might be, something at 0x abcdef, right? And y might be at 0x 1 2 3 4 5 6. Whenever you use x equal to y or x equal to y in objects in JS, with objects in JS, JavaScript internally always compare the memory address locations, right? So even if x and y have same properties, same values, everything same, they are still not equal because their memory addresses do not match. So x equal to y will always be false, y equal to y will be true because they refer to the same memory in the space. Similarly for x equal to x. Now, whenever the function re-renders, this object is created again for that particular function, right? So once the component mounts, React says that, hey, this object is not the same as the last object. Therefore, I need to re-render this. You're going to see that if you move this outside, this problem gets fixed because, well, every time now you have the same object to refer to. If you click on this, you can see this problem is not there because you're not recreating this object. But if you move it right here, then because you also have this as a dependency array value, this will trigger your counter1 update changes. So you have to be very, very careful. Interestingly, this will change if you have this as a state variables. So if you have obj set obj like this, and if you throw this inside a useState, what is going to happen is the very first time on the very first render, React is going to store this value inside this variable, and from that point onwards, it is not going to refresh the value. That means it's going to reuse the same object. So if you refresh now, if you click on this, counter1 gets updated, but if you click on this, counter1 stays the same, right? So that means you could technically you could have a behavior where let's say if you want to preserve the memory location of an object, you can throw that inside a useState variable, right? And then this object always refers to the same object unless you modify it. So yeah, that's a little bit of information you might want. This representation and actually just extracting out object out of this and mutating object refers very closely, is similar to another hook which React provides, that is useRef. We're going to be understanding useRef later on, but for now, this is how you can preserve the memory location sort of an object inside the functional component itself, while maintaining it inside your dependency array as well. So yeah, that's pretty much it for this video. I'm gonna see you in the next one. Hey everyone, welcome back. And in this video, let's just go ahead and take a look at the final piece of the puzzle inside useEffect hook, and that is the cleanup function. Now, what we have seen so far is that, let's see, we have, let's say the app1 is the, let's say this app first render is something like this. Then a state change happens. Then what happens is that you get a second render of this app function again, right? So the useEffect is called after mount, and again in the same re-render, if the useEffect includes a dependency which has been changed, the useEffect is called after re-render, right? However, what happens is that when this transition is happening from 1 to 2, you might want to do some cleanup for this particular function, right? For example, let's say you have established some listeners, or some event listeners, or something which you might want to clean up, right? So React gives you the opportunity to run that particular cleanup code just before the transition happens. So what do you mean by that? That means that you can return a function right here. You can name this function if you want. And this function right here says cleaning up effect of counter1, right? So what do we mean by that? Well, let's just hop back to the demo. And now if I see, we have a counter1 updated, but we do not see cleaning up effect. That is because the cleanup runs only when a function is about to tear down, the UI of a function is about to tear down, and another one is going to take its place. So if I click on this, you can see I see a cleaning up effect of counter1 and then counter1 updated again. So what you could see is that this runs the first time, this runs the second time, and this runs the second time as well, right? So the very first time only this runs. Once I click on the counter, this runs and this runs. The reason this run is because the first instance, the first UI of the app is going to be teared down, and the tear down was because of the variable which was about to change. If I go ahead and do the same thing with counter2, you're going to see nothing really happens because this effect does not care about counter2 at all. However, if I click on this again, you're going to see we get a cleanup effect of counter1 and counter1 updated again, right? If I click on this, cleanup effect again and counter1 updated. If I click on this, cleanup again, counter1 updated. This is super useful in the sense that, for example, when we'll be seeing about creating custom hooks, we're going to be seeing how you can use a callback or a cleanup function like this. So yeah, that's pretty much it for this video. In the next one, we're going to be taking a look at maybe how you can get started with custom hooks, and we can do a lot of good stuff, a lot of damage with just these two hooks alone. So yeah, that's pretty much it for this video. I'm going to see you in the next one. Hey everyone, welcome back. And in this video, let's just go ahead and take a look at the life cycle of hooks and how they are called, especially the useState and useEffect hooks. So you can see that I have console log spread all over the place, but just to walk you through real quick, we have a child component right here, which has console log inside the useEffect and the cleanup function, right? We have console logs inside app all the way. We can actually have console logs here too. Why not? We can say child rendered, right? We can right here say child rendering complete, and we can say this is child component and return, oops, not return, but const child component is this h1 tag, right? As simple as that. So now this is completely analogous to its parent component. So you can see in the app component, the first line we have is a console. Then inside useState, I'm using lazy initialization just to see when these console logs will appear. Similarly, inside useEffect, we have a console log. In the cleanup function, we have a console log. And before we return the component, we have a console log. So now let's just go ahead and refresh this, and we're going to see some interesting result. First things first, I am a child is visible, right? Now the reason this is visible is because show right here becomes true on the first useEffect call, right? So let's just do one thing. What we're going to do is I'm going to say if counter is equal to 5, let's say, I want to set show as true, right? So now if I go ahead and refresh this, we're going to have a smaller render console logs. So the first console log which we get is app render started, which is obviously what we'll expect once the function is called. The next one you can see is lazy init1 called. Now this, well, technically speaking, this is lazy init, lazy function inside useState. However, this is called immediately and the return value is set as the initial value. The reason this is lazy is because this function will not be called again at all, right? As long as this component is mounted, the useState functions will not be called again. Why? Because they have served their purpose and we have extracted out a default value from them. So this is the reason these functions won't be called again, but they are called the very first time. So once these are called, you're going to see lazy init2 as the second value, so that's fine. Then finally, you can see that appRenderEnded is called. So you can see right here, we could just call appRenderEnded casually, and you would expect that to happen as well, because there's no such console log going on inside this app component, because show is also false, so the child is not rendered. Therefore, we do not get these particular statements right here. Now, once the app render is done, you're gonna see we get a statement called counter updated. And the reason for this is that you can see the useEffect right here, which includes the statement called counter updated. So what you could see from this thing is that useEffect, well, technically this is not, you won't be able to see it exactly, but you can have my word on this, that useEffect would run when your component is mounted on the screen and your component is available to the user. That is, the pixels are displayed on the screen. How we can verify this is I can go ahead and put a debugger statement right here, go to console, refresh right here, and wait for it to pause. And you can see when it's paused on debugger, inside the console, you still have the 4 statements: appRender, lazy init1, 2, and appRenderEnded. However, you can see that on the screen you do have the contents pasted, right? You do painted, not really pasted. So the browser has already painted the contents for you. Now, whenever you click on this plus, you can see that the counter updated is called because the debugger is there, right? Now, once that is done, let me just go ahead and remove this real quick because we don't really want to have debuggers all along. So once that is done, let's just go ahead and click on the counter. So just to add a gap here, I'm going to click on this and you can see that we get 2 things: appRender started, appRender ended, cleaning up effect of counter, and counter updated. Now, why is that? Because when you click on this, you set the counter to the next value. Because counter is a state variable, you can see that React would internally call this function, that is to extract the UI, the updated UI again. So React will call this function again, which will run appRender started, right? This time you see that we do not get lazy init call because React knows that, hey, I already have the value for the state variable from the first run, from the earlier run. So I'm just gonna restore that if this value is not changed. If this is changed, I'm gonna, just return the latest value in this case. So you can say that in this one, in the second case, your counter is 1. That is the reason it is displaying 1 right here, right? Because the value in fact is 1. Then appRender ended basically just means you do not hit any of the lazy init. And once the app is rendered on the page, this useEffect cleanup runs, right? So this is important right here in the terms that once your component is rendered again, the cleanup from the last component happens. What does this mean? This means that I can have a debug of like value right here, for example. So I can say value right here, right? So now this will make things a little bit more interesting. So now if I click on this, you can see that the cleanup which has happened is of value 0, not 1, obviously, right? And the counter updated, which happens, is of value 1. So if I have value equal to counter, you're gonna see that now if I go ahead and refresh, and if I click on this, you can see the counter updated right here happens for value 1, but the cleanup has happened for value 0, which makes sense because the function which was mounted earlier was for the value 0, 1, right? And the counter has been updated for value 1. So the use effect, the latest effect, includes the value of 1, but the cleanup which happened was of value 0. So once that is done, that is all fine. Now I can have something like this again. So if I click on this again, you're going to see you get a similar thing again, but something interesting is going to happen on count of 5, right? Because we're going to be setting the child to true. That means this component will become available. So let's just go ahead and click on this now. You can see the following things happening. App render started, app render ended, cleaning up effect of 4, setting the counter to 5, which is again absolutely fine. App render started, app render ended, child. So what's happening here? Well, you see that what we did right here is that first things first, you set the counter, which resulted in a re-render. Then once the counter was updated, you re-rendered the application again in this block, right? So you set something in this block. Because of this thing, the app component re-rendered again. So you see this thing right here. This thing happened because you called the set show and set it to true. So the moment you did that, app render started again, right? Which is completely fine. Then, we skip the lazy init calls, obviously, just like we discussed before. App render ended. However, you see that the child rendering begins after we get this app render ended console log. Now, this might confuse you a little if you're thinking that, hey, how can app render end before the child logs are available, right? So according to you, you might think that you should have app render started, then these 3 statements, and then app render ended, right? But what you have to remember is that when something like this happens, this is transformed internally into something like react.createElement, and then not really JSX, but something like this, right? So this is what is happening internally. So what React is doing is react.createElementDiv with class name this. These are the children, and then this is something React is doing, right? So this app component is pretty much like a react.createElement app, and then props and so on and so forth. But it is totally up to React to determine when it wants to actually call the child function, right? So react.createElement internally will somewhere down the line call this child function, somewhere down the line will call this child function with appropriate props and values and all that stuff. But before it calls that, it just has that, sort of markup, and React will call it once you return it from the component, right? So this means that even if you're doing something like const child component as child like this, and if you do something like this, then also React is not going to mount or call this function, or you're not gonna see any sort of logs if this component is not really displayed on the screen, right? So that means this sort of thing is actually free to do. You do not hit any computational bottleneck or anything of using components before you render them, or maybe like displaying them like this before you render them, because React never really calls this component unless this is not really rendered on the screen. So this time it was in fact rendered on the screen. So that is why, looks like we actually refresh this. So now you can see that is why app render ended gets called first because, well, technically speaking, the render has not really ended. The render ends when you return the component and React renders it on the screen. So once that console log has done, then the child rendering starts. And as usual, you're going to see child renders, child rendering completes, just like app happened. And then once the component is mounted, you see the child updated console log, right? And if I click on this again, you're going to see that we get app render started again because of the counter, app render ended again because of the counter. And yeah, actually this I am a child will remain visible because we do not set this to false. So let's do a set show false, something like this, right? Refresh, and now click, 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 and you're gonna see that we get the child console logs just like we would expect them. And the next time you click on this, you could see something interesting. You can see that the app render starts, app render ends, child rendered. Why? Because child is also the part of the tree, right? So once this happens, once this counter is updated, the app re-renders, the child component is also visible. The show is not false right now, right? The show becomes false once the component is mounted and once this effect runs again. Then counter is not 5 anymore, counter is 6. That means this runs, and then again the component re-renders, this thing runs, and this counter becomes 6. This show becomes false. This was 6 before as well, right? This becomes false, and this is unmounted, right? So this is literally now not on the screen. So when it was on the screen, that is just after the counter has become 6, but the show variable has not become false, you get child render, child rendering complete, child cleanup called. Why? Because, well, it is a use effect without any dependencies, and child updated, right? So you can see right here that cleaning up effect of counter is called next, where the counter updated value becomes 6 and the show variable is set to false. Now once the show variable is set to false, you can see that app render started again, app render ended, and the child cleanup is called. Only the child cleanup is called, not the child updated and child rendered and all that stuff. And that is the reason is because your component is unmounted. Just like on mounting the very first time the child updated appears, similarly React will give you one last chance to do anything before the component is unmounted. And this is the place where you'll get your one last chance. That is the cleanup function of a useEffect sort of hook, right? So this cleanup function will run irrespective of if you have any dependency array or not, right? So for example, if you have a cleanup function in the counter one, this cleanup function will also run before your app component is unmounted. Similarly for any other thing which you're doing in the nested child components as well. So yeah, that's pretty much it on how the whole life cycle works and looks like. That's all for this video. I'm gonna see you in the next one. Hey everyone, welcome back. And in this video, let's just go ahead and take a look at how you can run asynchronous code inside a useEffect and how you should do that if you want to do that. We're gonna be doing that with the help of making a fetch request. Now this is not a React pattern you should follow, but this is just a demonstration of how it could be done. You should probably take a look at the advanced React patterns course if you want to actually know how to make use of fetch request effectively and efficiently in a React component. So you can find that course in the React Mastery Learning path, but for now, let's just go ahead and stick to this. So I'm going to be making use of this useEffect right here. And if I have not told you before, if you specify an empty dependency array, you can pretty much just run this function right here on the very first time. That's it, on the very first time of the function when it is mounted, right? So yeah, that's pretty much it. This could be, you could argue that this and useState something like this. This is equivalent, funnily enough, right? So this is equivalent sort of to this one. The only thing is that you would not get a callback or a cleanup equivalent in the useState sort of thing. And plus, this is a ugly hack, to be honest. You should always use useEffect if you want to run it once, if you want to run some sort of code once the component is mounted. And yeah, so let's just go ahead and really quickly inside our public folder, I'm going to go ahead and create a data.json file, and I'm going to say this is just hello world. That's it. So not really anything interesting, but now I can go ahead and take a look at data.json like this, which is going to return me hello world. This is of course will be different for you depending on how your playground looks like. But anyway, I'm just going to make use of fetch right here, and I'm going to say then text is text.json, and then we finally have the data which we want. So one thing which you can see right away is that we would not want to do something like this, right? And I can just show you message, set message, useState empty string, and I can say message like this, right? So I can say set message data pretty much dot hello, right? Because that is the property. Now you can see it technically works, but you should not really follow this convention. And bonus points if you can think why, right? Because you can see we already have a warning already, so it actually provides you an actual solution as well. So I'm going to tell you really quick why that is the reason. You see, when you make use of an async function, what happens is that by default in JavaScript, the moment you make a function async, it automatically returns you a promise, right? So it returns you a promise. And remember, what do you remember that what useEffect function should return? Yep, that's a cleanup function. So instead of a cleanup function, something which should be a function in the first place, you're returning a promise value. That is why you get a warning as well, and you get a possible solution to fix that as well. So we can follow a possible solution, and that is async function fetch data. For example, have this as this, and then just call it randomly, not randomly, just casually right here. No need to return anything or any sort of stuff, because if you return it, then it is a cleanup function which will be called later on, right? So now you can see it works perfectly fine, and that is how you should exactly do. So anyway, I hope that clears up the question of fetching data asynchronously inside a useEffect hook, and I hope that helps. That will be all for this video. I'm gonna see you in the next one really soon. Hey everyone, welcome back. And in this video, let's just go ahead and take a look at useRef hook in React. Now useRef hook is pretty awesome in the sense that you have access to an object, to a property in an object, which you can mutate. Now, hear me out. First things first, let's just go ahead and import useRef from the React framework, and you can do it like this. Next is you go ahead and create, let's say, I don't know, obj is useRef, and then write anything you want, 100 or 1 to 3 or whatever, right? And yep, that's pretty much it. So let's just go ahead and throw this inside a useEffect, or maybe like not even in a useEffect. Let's just go ahead and console log the ref object, right here. So now if you go ahead and refresh this right here, you can see the ref object magically holds an object which has a current property and a value 100, right? Now what happens is that, let's say if I have, you know, I don't know, something like useEffect, which runs whenever the obj changes, right? Now you remember that inside the dependency array of useEffect, it uses the triple equal to or double equal to or whatever, it uses triple equal to actually to check for the dependency changes. And because obj is an object with a current value of 100, we know that this effect would run if this object is being recreated, right, on any state change or whatever. So we can say effect ran, something like this. And let's say if I click on this, I just set counter to a value +1, right? Let's just quickly create a counter, set counter, why not? That's like a standard state variable for us. And I can say counter right here, right? So now if I go ahead and refresh this, you can see useEffect is not defined. Let's bring in useEffect. You can see that if I click on this, we get the counter increase and we get an empty console log for some reason because of this. Let's remove that, refresh, and now you can see that we do not see the effect ran console log running. That means on every single render, every single new render which is happening, this object is not changing. This is important. So what's important is that useRef on every single render will always return you the same object. So this means that you can store anything you want here, you know, any number, any string, anything you want here, and on every single render you're gonna have the same object and the value can be accessed using the current property, and not only just accessed but also modified, right? So as to say, for example, let's say you want to have whenever the counter changes, for example, useEffect, whenever the counter changes, you want to say I want to multiply object.current, I want to multiply it by 5, right? And let's say you have a value of 5 here. So what's happening here is that you just multiply the object.current value, and yeah, that's basically all you do. And you can just say console log new object ref is obj right here. Now if you go ahead and refresh this, you're gonna see that if I click on this, we get the new object ref as current 125. If I click on this, we get 625, that is 125 times 5, right? If you click on this again, you get 625 times 5, and so on and so forth. So what's happening here is that you can see object.current can be mutated, but if you just, you know, if you just try to update the object.current value, it will not trigger a re-render. So if I go ahead and comment this one out and just do something like this and say, you know, something like this, 2 and 1, just to distinguish them, refresh. Now if I click on this, you can see that all we get is a new object ref, and that's pretty much it, nothing else. We see that there is no update, no render running, no effect ran, nothing is happening, right? You can also make it like this so that you detect every single re-render, and even now, even when you're detecting every single re-render, you see no re-render is happening, because when you mutate the current property inside a useRef thing, nothing really happens, right? Because React does not inform you about changes of this current property. So what's the use case of this? Well, you can think of useRef and using this thing as sort of storing a mutable value inside your function, inside your function component function, right? And why would you want to do something like this instead of storing it in a global scope? Well, you get free memory cleanup right here. For example, let's say you are storing some heavy JSON object, maybe like this. So your current value would consist of all that heavy JSON, and then once your component is unmounted, this memory would be freed, right? However, if you have an object which is like this memory will not be freed because it's in the global scope of at least this component file, right? Not if in the whole scope, but it is still in global scope. So this is like one use. Another use is that you can actually attach the ref objects to the elements as well, which is sort of another use case, which we'll see in the next video. But let's just keep this one to just the simple mutable application of the useRef hook. So that is all for this one. I'm gonna see you in the next video. Hey everyone, welcome back. And in this video, I want to quickly show you a use case of useRef, and that is to get access to DOM elements directly. Now you know that in React, the reactive way of doing things is to not really interact with DOM directly. That is, not really use document.getElement by ID and query selector and stuff like that directly. But sometimes there is no other way, right? You need to hook into your DOM element. So one of the ways you can do it and still keep it sort of reactive is to make use of a ref. And that means that if you have, let's say, this as a, not really, let's not keep it div, but let's keep it ref. And if you go ahead and do a ref attribute like this, if it's confusing you, I can also say that this is element ref. This does not really matter. So once you do that, and once the render completes, what you can do is you can go ahead and say console.log elementRef.current, right? Now this, pay close attention to this. This is super important. You know that useEffect hook runs after the component has mounted and the browser has painted it on the screen, right? We know that. That means this particular thing means that when the component mounting process and everything is done, what will happen is that this ref attribute will set the current value of this particular ref as this HTML div element. So what you can expect to see ref element right here is that this should contain your div element. So let's just go ahead and refresh this and let's see. So you can see this ref element is directly this div right here. However, pay close attention to how this operates. So let's just go ahead and, for example, I have something like, on click, I say set counter value +1, right? So we are back to where we were. And now I am toggling as the p tag. So I just say that, hey, if value modulo 2 is 0, that means on even numbers, I want to show it, and on odd numbers, I want to hide it. And if I give a ref to this p element, what do you think the console logs would look like? Let's see. So I'm going to go ahead and refresh this, and I think we have an error, set counter. Yep, this is not value, this is actually counter, right? So let's refresh this, and now you can see we have a ref which is completely fine because this p tag is in fact available on the page. But when you click on this, you see the ref element is null, right? So you have to be careful when you're trying to access element.ref.current. For example, element.ref.current.tag name. Right? So if you're doing something like this, if you refresh this, you're going to see the first time you get the correct tag name, but the next time there is an error. So you have to be careful that this could be null if the element is not mounted on the page, right? This is important. With that being said, the useRef thing does not has a callback, just like we discussed in the last video. This does not has a callback inside it, which triggers whenever the current property is set, right? We talked about this in the last video as well. There are useCallback ref and all that stuff. There are external hooks, but the internal hook which comes does not come with a callback, right? So this is just a sort of a free floating object with a current property, which is mutable. And every time a re-render happens, it's going to assign that particular current property, if you are supplying this as a ref to some element, to that particular HTML element itself, right? But if you know that the element will not be hidden, or will not be just going away randomly, then you can of course very confidently have a inner text or inner HTML, or whatever you want to do. It'll just work absolutely fine, right? So that's how you make use of useRef as a second thing as well. Another interesting use case of useRef is that you can pretty much just go ahead and have a useRef of something like, renders, for example, and you initialize it with 0, right? And on every single render, you say renders.current is plus equal to 1, because we know that this is a mutable value. That is, it will not trigger any state updates, not trigger the re-renders. So you can do something like h2 current renders and renders.current, right? So you can do something like this just to keep a track of how many renders you have already done. Now this is an interesting part. You see that actually the value right now is 1. The current renders value right now is 1, because we know that useEffect runs after the rendering is done. But we still see 0 because, once we set this to 1, there is no update to update the UI. So to actually, just to make more sense of the data and keep it real, rather, you should do a +1 to it. So now if you refresh this, you have current renders 1, which is the initial render. Then if you click on, if you do any sort of render, it'll just update the counter. And if there is any other re-render, for example, from some component, or for example, if the parent props changes or anything happens, this current re-render would update automatically. But I hope you understand why I put a +1 here, and why on the initial boot, this actually showed 0 initially if there is not +1 here, right? If you do not understand that, I would highly recommend you to watch this video and a couple of videos about useRef again. So yeah, we discussed this in a great depth in the previous video as well, if you skip that. So yeah, that's pretty much it for useRef. I think we have covered a lot of stuff, a lot of ground along the way, and I hope this puts things in perspective. In the next video, I'm going to show you a way how the useState can act similar to how useRef looks like. So that is all for this one. I'm going to see you in the next video really soon. Hey everyone, welcome back. And in this video, let's just go ahead and take a look at how you can make use of useState as a useRef thing, right? So let's say I want to make use of this renders thing again. So what I can do is, because I know that useRef would create an object like this, and now this object is same on every render. These two things are important, right? The current property is not so important, just given the fact that this is not being monitored. So what you can do is you can have a renders, which is a useState, and the state is current with 0, and then you do a 0 right here. Let me just tell you what happened here. So this renders and this renders right here is similar, right? So I can pretty much replace this renders like this, comment this out, and if we take a look, refresh, if I click on this, you're gonna see it works pretty much in a similar way, just like useRef worked. So what's happening? What the hell is happening here? Let's take a look at that. So you see that useState will actually return you two values, right? The first value is the getter, right? And the second value is the setter. So the getter in this case would be an object with a current of 0, right? You're gonna get an object whenever you do, for example, r set r, something like this. Then the r is this object, and the setter will be a function which will allow you to update the whole object itself, right? Instead of this object, if you want something else, you can place that. But if you just pick up the getter, you lose the setter along the way. That means you're not using the setter at all. So it's like saying something like this and then never using setter, right? So instead of doing something like this, I just did render and I selected the 0th element, which is just our getter element, right? So once I did that, I have this object with me. Now, remember that you can only modify your state with the setter object. That means React will only trigger a re-render when you call the setter object of the useState hook. It will not trigger a re-render if you try to modify, manipulate the state directly, right? Because it just doesn't know, it just doesn't care that you are mutating the state, right? Because every time you call the setter function, then it's going to run the new occurrence of that app function, you know, just like we discussed how it calls it again, and then it is going to re-render all the stuff. But in this case, we just lose the setter. That means this value will never update, and because this is an object, React will always keep on returning you the same object from the useState, because that was the original value, right? And you can mutate and play around within this object if you want, right? In fact, you can just keep, you know, a bunch of properties, more properties, prop 1 as 100, prop 2 as 200, and then you can pretty much just, you know, do a prop 1 as plus times equal to, stuff like this, and you can make use of this if you want to, right? Again, similar difference. Why would you want to do this and not something like this? The reason is you do not want to pollute the global scope, because this will not be cleaned from the memory if the component unmounts, right? But the state variables, the refs and everything will be cleaned automatically for you. You don't have to do them. So yeah, that is another way of using the mutable feature of refs through useState. You should not probably use this. You can pretty much just stick to useRef only if you want to, but you should know that this is possible, right? So yeah, that's pretty much it for this video. Hope you learned something new. I'm gonna see you in the next one really soon. Hey everyone, welcome back to another video in which we'll be taking a look at useReducer in this video. So far we have seen how useState and useEffect work. Now we have actually also created the this.setState from class-based components with the help of useState alone. And we basically touched down on how useReducer would look like in that video. So let me just go ahead and quickly do that again. So what we did last in the video, which was you know, creating a this.setState from class-based components, was something like this. So you would have, you know, useState imported, and let's say you have an object obj1, obj2 as 2, right? And this could be 1. Now, if you want to have a setState like thing, what you'll do is you'll create a setState function. You will accept, let's say, new state, and what you're going to do is say setState internally old state, and then return something like old state and then new state, right? So you see that if you're doing this complicated logic already, React provides you the ability to do something like this, and with a much more precise control over things, because, well, it's more or less the same thing, but you'll understand. So this is actually a forced sort of implementation of another hook in React, which is called as useReducer, right? Why useReducer? Because it accepts a function which is called a reducer, which reduces your state to a new value, right? So let's see how that works, because let me just go ahead and create a counter here. For example, let's say this is state, and I want to say on click, or this should be rather state dot, let's say this is counter, right? State dot counter, and on clicking, I want to say it set state counter is counter state dot counter plus 1, right? So now if I go ahead and click on this, you can see the counter going up. All right, and of course you can also have an h2 showing us the state.obj2, and we could see that the state.obj2 will not be lost when we are clicking on the counter. Now let's move this logic to useReducer, and the first step we're going to do is we're going to import this, right? Next up is I'm going to try to create a similar logic here. So I'm going to say counter, set counter, and I'm going to say useReducer, but this time the first argument right here will be a reducer function, right? So this function will be called whenever set counter is called. Now bear with me if you do not understand this. So let's say I have a random function here, right? And if I go ahead and create this function, what you're going to see is that it's pretty much like useState alone. Let's just simplify useState a little so that we can see the exact differences. So I'm going to have useState as 1, and let's say I have this as set counter as counter plus 1, and this one as just the counter, right? All right, let's see. So this still works, right? Now we want to get rid of this, and we want to see how the useReducer looks like. So we're going to have a random function. Now what happens is that this random function right here, the value which this function returns will be set as the new counter value, which is this one. You see, this is pretty similar to how this function sort of implementation worked. That is, whatever you did inside this thing and returned will be set as the new value. The only difference is that the function, the set state, instead of you are calling set counter directly, React internally calls a random function which it observes the value it returns, and the value which it returns is set as the new value. It's as simple as that. So let's get rid of this, and let's say I want to return 5, for example, right? So once I do that, what you're going to see is that if I get rid of this, in fact, and I say set counter as, let's say, that's it, because we are not really passing or accepting any arguments at the moment. So if I just say set counter and have counter as the variable, what do you expect will happen? Well, it is not having any value at all right now, but when I click on this, you can see a 5 suddenly appears. Why? Because when I click on this, React internally ran this function, that is random function, and this function returned me 5, which got set as the counter variable value, right? Now, this useReducer also accepts a default value, just like useState accepts, and that is the second argument. So I can specify 10 here, and now when I refresh this page, you're going to see that our counter starts with 10, and when I click on that, it becomes 5, because you can see that when I click on that, this function runs, this returns 5, that gets set, right? Simple as that. Now, what you can do is you can get access to this counter right here as the first argument by default, right? So you do not necessarily need to pass, counter or whatever. here, you do not need to pass this. Even if you do not pass it in the set counter function, which is returned when React is calling your reducer, that is this random function. Remember that these two are different functions, right? When you call this, you tell React to internally just call this random function sometime in the future, right? This is not a synchronous call. If you call this, React will not synchronously call this. React will call it on the next render. So what's happening here is that when React calls this function, it automatically calls it with the updated value, or not really updated, with the older state, right? So if you go ahead and return a state +1 here, what's going to happen, if you can guess it, it's going to take this counter value, which is 10 by default. When you call this function gets called with 10 here, you return 11 and the value becomes 11. On the next call, a similar process happens, right? So if I refresh this, we start with the 10. If I click on this, we become 11, 12, 13, 14, 15, and so on. So I hope you understood how useReducer is working. The only difference which is inside of useState and useReducer is that useReducer will put a sort of a middleware, right? A middleware function which is executing before your final state gets set. It is useful if you're trying to manage, just like I showed you, those multiple object states, or just want to have some custom logic. In fact, you can have a very close sort of application of Redux sort of thing as well, right? Because what you can do is you can name this function, this set counter, as a dispatch method, and then accept another argument, which is an action. So more on that later, but what you can do right now, you can see that, well, it accepts the state by default, right? Now you might say that, hey, what if I want to send some data from here? Let's say you want to have a step value, right? So how do you do that? Well, you can do that by just sending it like this as an argument. So if you do step as 20, for example, what you can do is the argument which you call the set counter with, it's gonna internally call your reducer function with that argument as the second argument. Why? Because the first argument is the state itself, right? So what's happening is, if I can just explain you the flow of execution. Well, this is not really comment, it's not Python. So let's go ahead and make use of backticks. So what's happening here is that you can see you call set counter, right? React schedules a call to random function internally. Sometime later in the next render, React calls random function with counter as the state, right? If you pass in 100 here, React will call random function with counter and 100, which is the second argument, right? So you receive this 100, or in this case a step value, in the second argument, and then maybe you can just increment it with a step. So let's get rid of this. Let's refresh this right here, and now you can see that you are incrementing in 20 steps, right? If you change this to 15, it will work in increments of 15. So you get the idea. So this is a very basic tutorial on useReducer. I hope you understood the core concept of it. In the next one, we're going to see a little bit of more use case of useReducer and how you can turn it into a Reduxy-like thing. But yeah, that's pretty much it for this one. I'm going to see you in the next video really soon. Hey everyone, welcome back. And in this video, let's just go ahead and take a look at how you can create a dispatcher function and a Redux-like effect with useReducer as the hook. Now remember that useReducer, the way it works is that when you call the setter function of useReducer, it internally calls your reducer function, which in this case is a random function, and you can pass in a single sort of argument as well, right? So it sends you state by default, it sends you a new argument, and it calls your reducer function. You can go ahead and make use of this thing in order to create a sort of a dispatcher way of updating the state. And what do I mean by that? Is that you dispatch certain actions, and based on the value of that action, something is performed to the state. Now, hear me out. Let's say you have a couple of buttons, right? So this button here says increase the increment, right? And I'm just going to go ahead, and when I click on this button, I say increase increment. And what I'm going to do in this function is that I'm going to try to increase this step value right here, right? So what you might be tempted to do is have something like step and set step useState 20, right? And then maybe you can say set step as step +1, right? You might want to do something like this. And I'm not saying that it's wrong or something. I'm just saying that, you know, if you click on this, we get 20 increment. Then I click on this. Now we get 21 increment. Now we click on this. Now we get 22 increment. It's perfectly fine. It's not wrong. But you see that you have already like broken down your logic into two things, useState and useReducer. And the whole point of using useReducer is to bundle and bring together complicated state-based logic, right? useReducer is not a very good choice for, you know, if you just have a single value to return. So what we can do is we can refactor this application a little bit to make it more organized. And the way we will do it is we'll get rid of this first of all, right? And inside of this function, I'm going to rename this as state and this as dispatch. And I'm going to tell you why. Inside this thing, I'm going to set a dispatch action and say type as increment counter. Now, why did I do that and what will happen? So what's going to happen is when I click on this button, this dispatch gets called. This dispatch internally calls this random function with state as 10 and step as this object, right? I hope that's clear. That state will be 10 and the step will be this object when it's called. We know this from the last video. Now let's do a little bit of more refactoring. Instead of initializing it with a, 10 as the variable, I'm going to initialize it with, let's say, counter 0 and step 1, right? So now we have another update. The state will become counter 0 and step 1, and the step is still this argument, right? I'm going to rename the step to action because that's like more of a convention. And now we have something like this. So what exactly is happening here is whatever value which I return from this will become the state again. And obviously we would want to return an object itself because we don't really want to have, crashes and everything, because we will be expecting an object in a render function as well. So what we're going to do is follow a very common practice, and that is switching over action.type. Remember that we are calling this dispatch as an object which contains a type property, right? So what I'm going to do is I'm going to say that, hey, if we have a type of increment counter, what I want to do is I want to say return a new object, which is of course the already existing state, whatever it was, but the step in that state is what it is, state.step +1. You can do something like this, or you can take it one step further and you can pass in a payload here. So you can say payload of 1, right? So now you can remove this one and completely depend on the dispatcher action thing. So now you can say action.payload, right? I hope that makes sense. In case of, case default, what you can say is pretty much, I don't know, you can just either return the original state, or some people also prefer to like throw an error here that, action not found, whatever it is. Although I would recommend you to throw an error, because if you are having a typo or anything, that will be easier to detect this way, but it's up to you. So once you have done that, what you're going to see is that, well, you can now increment counter, but yeah, I mean, or actually we are not really incrementing the counter, so it should rather be increment step, not counter, right? In case of increment counter, which should be the actual name, what we are trying to do is return state, and then counter is state.counter plus 1, right? Again, you can have a, or not really plus 1. In this case, we want state.step, right? Because that's, well, that's the whole point of stuff, right? So yeah, I mean, that's how you're going to do it. And just to put all the things in action, what you're going to do is right here, you're going to say dispatch, or maybe like, get rid of this and say increase counter, and create another function which just dispatches the action of incrementing the counter. So in this case, we'll say increment counter and no payload, because we don't need a payload in this one, right? So we have this, and it looks fine. And we can change this to state.counter, right? And you can also change the h2 and say, for example, current step is state.step, right? So now you can see the counter is 0 and the current step is 1. So whenever I click on the counter, we are incrementing it. If I increase the increment, you can see now if I start clicking on the counter, it increments in the current step 1, right? So if I have 5 here, it works fine. Similarly, you can create a decrement button as well. So for a decrement, increase increment, decrement increment, not the best naming convention, but anyway, who's watching? Decrement, increment. And in this case, you can either go ahead and create a new action and then specify a negative here, or you can simply say a payload of -1, right? Because, well, plus minus becomes plus. So you can go ahead and say this as decrement the increment, or the step, right? Step, that's a better name. So increase the step, decrement, decrease the step. So when you do a decrease, it becomes 0, -1, and when I click on this, you can see the counter runs backwards. So now if I go ahead and increase a step, the counter again runs forwards. If I go ahead and decrease a step, the counter again runs backwards. So yeah, that's pretty much it. I hope you understood how you can abstract away a very small counter inside of a useReducer, and this is a much better way of handling a small little counter instead of having to maintain multiple state variables and do all sorts of stuff, because this makes things much more cleaner and easier to maintain, right? So as a general rule of thumb, you can think about useReducer, using a useReducer whenever you have some complex or complicated state to manage here, right? So yeah, that's pretty much it for this video. I hope you learned something new. That's all for this one. I'm going to see you in the next video. Hey everyone, welcome back. And in this video, let's just go ahead and take a look at a new hook, a special hook, and that is useMemo. Now, useMemo is a special hook and something I would recommend to really learn before you use it, and why you should use it in the first place. Alright, so first things first is that if you're using this hook ever, that means you are doing something computationally expensive. If you are not doing something computationally expensive, do not use it. Now, why do I say that? That is because it just adds a little bit of readability complexity to your code. So let's take a quick example, take a quick look of what this is. So I'm going to say const value and useMemo, and I'm going to pass this a function which returns 100 and an empty array. This might look very similar to like useEffect, right? You have a function to call Well, you're returning a value, that's the only different part. And you have a sort of a dependency of things. So what happens if I do a value right here? You see, let's see, we have 100 right here, just like you would expect. So what is the difference between this thing right here and let's say value 2, which is just 100? So you might ask me, what is the difference between value 2 and value? Well, technically there is no difference because these both are 100. But what is happening under the hood is that useMemo is going to run this function which returns you 100 only once. That means because there's no dependency of things which are changing, it memoized that value. It remembered that, hey, nothing changed, therefore I do not have to run this function again to extract out that computationally expensive value. You can have a very, very computationally expensive task here, calculating primes or the answer to the universe and everything, and then return a very simple value. And if you do not have a dependency, or maybe like if your dependencies are not changing, this will not be computed again. So to give you an example, let's say I have not really console, but const state set state as useState as 0, and let's say I have I don't know, state variable as state, right? And let's say whenever I click on this, I just set the state to something random. Now the only reason I'm doing this is to trigger a re-render, right? So when you trigger that re-render, let me just go ahead and console log I am inside useMemo, right? So we have a sort of a setup like this. So now if I go ahead and open this, looks like we have an error or something. useState is not imported. So let's just go ahead and refresh this. And now you can see the state variable is 0. And if I go ahead and open the console here, we should be able to see I am inside useMemo, which is rendered twice. And again, the reason for that is because we probably are inside React strict mode, right? So let's just quickly go ahead and remove this. There we go. And this should drop our rendering problems. So now we should be rendering it just once. Now, when I click on this, you can see that I am inside useMemo is not getting called, right? Because it has memoized that particular value. However, you can see that this value 2, for example, value 2 will be set again, right? So if I have a console log like this, you can see that I can refresh the page and I can start clicking on this, and you can see value 2 will be set again, is happening again and again, right? Now, what if this is just not a number, right? You can also have objects in here, and one of the reasons useMemo is used is that the referential equality here is preserved. You remember that I showed you an example where you can have an object here, const obj, and x is equal to 1, for example, and inside useEffect, if you have this obj as the dependency, this will run always. This will always run. Why? Because on a new render or a new cycle render, you can say did obj change. So you can have something like this with an obj. This will always run because objects are compared referentially. That means where they point in memory. And React uses triple equal to, or not really triple equal to, but object.is internally, which is kind of like triple equal to only. And these two objects, the first one in a previous call to this app function and the second one in an updated call, the two objects do not point to the same location in the memory. So that's why this effect runs. So if you go ahead and take a look, refresh this right here. Let's see, useEffect is not defined. Let's just go ahead and put that here. And now if we go ahead and refresh this, we're going to be seeing that objects are not valid. All right, let's see. Where did we go wrong? Here, right? So if we go ahead and refresh now, you're going to see we get did the object changed as the log. And whenever I click on this, you can see we are getting did the object change log as well, even though the object is not really changing, right? However, if I do the same thing with useMemo as memoized value, so I can have an obj here and say return count as 100, right? So now I can say obj is like this, and maybe get rid of this, and maybe just say obj.count, right? And get rid of the value 2 as well, and probably get rid of state as well, or maybe not, that's fine, right? So once we do that, once I refresh this, you're gonna see that we get the first did obj change as the console, but never again. Why? Because this count 100, this object is always the same. This is always returned in a same way, right? That means you always point to the same object in the memory. So yeah, I mean, useMemo is used very rarely. I mean, in your React coding experience, in your React career, if you're a React developer, you will not see a lot of places where useMemo will be used. But the places, if you put it in the right places, in the right computationally expensive places, this could be really, really helpful. For example, I can give you one quick example of where I use useMemo is in the calculation of this tree-like structure. Because on CodeDam, what happens is when you are opening this folder or closing this folder, there are certain changes in the tree of the file structure, right? So useMemo is used to save the computation involved in calculating a tree structure, because this component might get re-rendered for some other reasons. For example, you know, some prop gets updated or a WebSocket connection is established or whatever it is, right? I don't really want to compute and recompute the whole tree of the files again and again. So that is why that is inside a useMemo. If you're doing anything simple, you know, which is not so computationally expensive, it's much better than just go ahead and put it directly instead of, like, you know, complicating your code with useMemo. But I just showed you how you can do that, and yeah, that's pretty much it. So one thing you can also do is, for example, if you want your useMemo to, let's say, recompute the stuff whenever state changes, then you can do something like this, right? So now let's say I say that if math.random is greater than 0.5, I want to say math.random. Otherwise, I want to say state itself, right? So what's happening here is that 50% of the time I will trigger a re-render and 50% of times I won't, right? So let's see how that works. So now if I go back, refresh this, and if I click on this, you can see there's no re-render. Click on this again, no re-render. Well, I think I'm clicking on the wrong element. This is H2. Click on this, no, click again. So you can see I'm inside useMemo gets called because the state changed. If I click on this, no re-render, click on this again, I'm inside useMemo. Why? Because the dependency got changed. Pretty much like how useEffect works. So you can specify the dependencies which are required inside useMemo for computation of the thing. And once the dependencies changes, it's gonna recompute your value and not really compute this function again until one of the dependencies changes. I hope that makes it clear. I hope you understand how useMemo works. Pretty important function if you have, you know, a bunch of prime factorization going on the side here and there. But other than that, if you find yourself using it, try to take a step back and see if this is really, really required. So yeah, that's pretty much it for this video. I'm gonna see you in the next one really soon. Hey everyone, welcome back. And in this video, let's just go ahead and take a look at useEffect. callback hook. Now this hook is pretty simple to understand once you have understood useMemo and how it works. Now just remember that just consider if you have, let's import useCallback as well. So the way useCallback works is that it is a special case of useMemo. If you return a function from this, right? So if you say something like console log hello there, right? I don't know, maybe like return a div, or maybe like h1, say memoized component or something like that. So what's happening here is that you can see that you have now memoized a function. Remember that with useMemo, you can pretty much memoize anything, right? Whether it's 100, whether it's a string, whether it's an object, or whether it's a function itself, right? So what's happening now is that object obj right here is now a function, and you could probably call it like this, and you're gonna see that when you do, you get a memoized component like this. Now the difference between useMemo and useCallback is that useCallback would directly accept a function which it has to memoize, right? So what I'm going to do is I'm going to say object2 is useCallback, and this function right here, you can see that this function is the memoized function itself. And of course it will also accept a dependency array just like useMemo, and you can pretty much go ahead and call object2 here, refresh this page, and it will still work just the same way. So what has changed? Well, you can see that useCallback would not call this function, but it will return this function as it is. Not really as it is, but it will return the instance of that function if the state has not changed. Just like with objects, for example, if you have an object like hello1, and if you try to do a referential equality of the objects between two function renders, you will realize that these two objects are not same. Similarly, for a function, you will realize that these two functions, the function 1 and the function in the next render of the application, will not be same. Why? Of course, because you are recreating the function, and just like objects, functions are not equal as well, right? They are not compared on their toString value or anything. They are compared with their referential equality. So useCallback right here will return you the same function over and over again, right? A special use case of useMemo. So yeah, I mean, that's pretty much it. If you want, you can always, you can almost, not really even almost, you can always go ahead and make use of this equivalent instead of just going ahead and making use of useCallback, but it's up to you. So yeah, that's pretty much it for this video, and I hope you learned something new, and I'm gonna see you in the next one really soon. Hey everyone, welcome back, and in this video we're going to be taking a look at context in React Context API once and for all. Now this is a super important topic in React, and you should really know about how Context API works, and it is very simple if you understand it. So first things first, you have to import two things from React, and that is useContext and createContext. Once you do that, the first step is to create a context, and you can think about context in a very generic terms, right? Just like the context word means in English, that you're creating a context of things you want to store globally, or at least, in a shared space, if not globally. Although the most common use of context is to create a global store, but you can have sort of mini local stores as well across your React code base. So the first step is to create a context, right? So I'm going to have a context, and I'm going to say create context and pass in null, basically. Why null? Because you could pretty much get away with anything written here because we immediately override this value. So at the moment, just remember, you can pass anything in the create context, right? Because this value doesn't really matter. So I can pass in null, I can pass in whatever you want. Next, this context right here gives you a provider. Now what this provider is it's a single shared parent which will fill in the value which should be shared. Now hold on, let me tell you how this works. So I'm going to go ahead and create a context.provider. Now there is nothing special about this .provider, it's just that this is a JSX element which is returned by this create context, right? So you have to use it like this only. So context.provider is a JSX element which helps you inject a value. Now whatever this value is, this value can be technically accessed by any child down the line, right? Which is super cool without actually doing all that prop drilling. So let's see, I have a hello world here, for example, or not really hello world because that's pretty much what it is written. So let's say Mehul coded codam, right? So we have a very simple string right here. Now let's say instead of this hello world, I have a remote component, and let's say I go ahead and import this remote component from a different file. Let's just go ahead and create a remote component.js, and right here I am pretty much just going to make use of the same thing, but just going to say this is remote component and this is a div and maybe like I am remote, right? That's it. So this component, you can see that we have not drilled props inside this component, right? So if I go ahead and give it a refresh, this should probably work. You can see we get I am remote. I can say I am local, something like this. And inside this remote component, we can go one step down the line, component 2, and I can say function remote component 2 return h div h3 I am even remote, right? So we have a little hierarchy with us, which is consisting of a local component in which the context is created, remote, and even remote. So the beauty about context is that once you have wrapped it inside a provider, you don't have to drill props. What you can do is you can directly go ahead and access the context value from the component itself. And the way you do it is as follows. You say your value is useContext, which is again a hook which you can import from React. And right here, you have to pass in the context which you have created here, right? So a better way would be to move this piece of line in a different file, or maybe like export it if you want. But a better piece, which is something I would recommend, is to go ahead and create it in a different file. So we can pretty much go ahead and say store.js or something like that. So you can say context is create context, and you can import create context from React, right? And then you can say export default context, something like that, right? And then you can go to maybe like app and say import context from, let's say, store, right? Store. So once you do that, you already have access to context.provider, but you can do the similar thing here as well. So, you know, it can act as a central store sort of thing now. So I give it this context inside useContext, and now I suddenly have access to this value. So if I go ahead and echo out this value, you can see we get Mehul coded codam directly out here. as this particular value, right? We did not inject it. We did not do any funky stuff. We only just shared a piece of information in different files, and that is just the context, right? Now, you can do pretty interesting stuff with this. Why and how? That is that you can share, because you populate your context inside value, you could probably go ahead and say something like that, hey, I want to share an object, not a string. And you can say, let's say app state, set app state, use, or maybe like, state and dispatch, why not? And say useReducer here with a reducer function and a default state. Let's say your default state is theme is dark, right? And you can have a function reducer which says state and action. We're going to follow a typical React Redux practice. So I'm going to say switch. This is something which we have done already, right? So I'm not going to get into a lot of details here. So I'm going to say toggle, or not really toggle, let's say set dark theme. And I'm just going to say return state and theme is dark. And similarly for light theme, I'm going to say set light theme, light, li, set light theme, and this one will become light. Now, how this would work is that we initialize it with a dark theme. We have a dispatcher and a state with us. And what you can do is put both of them like this, right? So now what's happening is that you have a shared context space. You access it like here, and you can say that mode currently is value dot whatever value you have stored inside the theme variable, right? So if you do value dot theme, and if you try to give it a refresh, if we did everything right, we should probably see something, but we do not. We see useReducer is not defined. So let's see. Let's import this right here. And now if we go ahead and see, we get the output. So the mode at the moment looks like it is nothing. And that is because we have to destructure the state and dispatch both, right? Because now we are not storing a simple object, but a simple string, but an object, right? So now you can see the mode is dark. So what you can do is when you click on this, you can pretty much call the dispatch function just like you would usually call, and say the action type is set mode light, right? Or set light mode, whatever it was. Let's see, set light theme, not light mode. So now when you go ahead and click on this, you can see the mode changes to light, right? And you can say, you can check here if state.theme is dark, you want to set light theme, right? Otherwise, just go ahead and dispatch an action which sets the dark theme. So you can say set dark theme here, and this will absolutely just work fine. And now you are toggling the values which are in the global scope, right? You can do pretty much the similar thing inside this remote component as well. So you can go ahead and say style, and you can say background is let's say computed, and text, or not really text, but just color is also computed. So we say the background is equal to state.theme is dark, then it's black, otherwise it's yellow. Similarly for color, I say that, hey, if state.theme is dark, I want to say white, otherwise I want to say black, right? And that's all we want to do. So what's happening here is now you can see on the dark mode, we get a black background and a white color. But the moment I click on this, we get a light background and a black color. And you can actually just move this to just an H1 so that the remote component is unaffected. So now if you click on this, you can see you are toggling the value in both the components, right? You can see that, when you click on this, the value changes and propagates in both the components. Now, a big caveat with this approach, which you should know, is that React Context will re-render every single component, even if you do not need the part of the state from that component. And the reason for that is because, you can see that useContext right here cannot really determine that whether you will use, let's say we only have a couple of values here, but assume that, for example, inside this, we also had, let's say, some custom prop and set 200, right? And I don't know, assume that this some custom prop is changed from 100 to 200 by some action in the parent component. So even though your application, this remote component, never really uses some custom prop, it will still re-render, right? It will still re-render because the context value has changed. So React, what it does is that with useContext, it will simply dispatch updates to every single component and tell them to re-render with the fresh values. This is a fundamental and a significant difference compared to Redux, for example. Redux does not do that. Redux can specifically update components depending on what values they need. And to fix this, there is an ongoing solution, which is another hook called useContextSelector. But we're not going to get into that at the moment. It's not very popular right now. For simpler use cases, you can stick to useContext. If you need complicated use cases like, heavy state and, sharing a lot of state in very deeply nested components in a lot of components, Redux is still probably a better approach. So yeah, that's pretty much it for the useContext hook. I hope you learned something new. If you did, that's great. I'm going to see you in the next one. Hey everyone, welcome back. And in this video, let's just go ahead and try to create our own custom hook, a very simple hook, and see how we can go about that. So first things first, the convention in React to create a hook, as you might have seen by now, is that hooks start with the keyword use, right? useState, useEffect, useReducer, useContext, all that stuff. So the way you do it is, first of all, you realize that, well, a hook is just a regular function. Therefore, you're going to just create use, let's say, counter in this case, right? And then you're going to accept basically whatever you want as the arguments, right? Because like useState accepts either a default value or a function. You can accept, let's say, a value, right? Or an initial value. And what you can do is now you can start composing your hook. Now, what you have to remember is that hooks, basically the higher level order hooks, basically consist of, are created of smaller hooks, smaller fundamental hooks, useState, useEffect, stuff like that. So our counter, this hook would sort of provide a wrapper around creating any sort of counter, right? And then incrementing or decrementing it. So let's say I want to create a counter, count, set count, useState, and I'm going to initialize it with initial value, right? So there's that. Next, I'm going to say that, hey, my add function, let's say if I want to increase the counter, is something which does a set count and count plus 1, right? Something like this. And a subtract function is a function which does a set count of count minus 1. And then finally, I can return all these, count, add, subtract. Now you might want to do like count, add, subtract, which is again fine. It just changes how you would destructure the values here, right? So if you have an array-like notation, you can do a number, add, and subtract, something like this, and say use counter 100, right? And you can say counter 1, add, and then number, right? And you could probably say on click add, something like that. So once you do that, once you refresh, we see we have not been able to make this work because useState is missing. So now I can see counter is at 100. Now whenever I click on this, it can increment. I can create another button which can show you how it can decrement, but you know how that would work. Similarly, if you return it like this, count, add, subtract, you have to destructure it with an object notation, right? Because you can see that this is a regular function just composed of smaller hooks, right? So now you have count, add, subtract like this, or maybe like sub, not subtract, because subtract is not defined at all. So now you need a count here, and then it'll work in a similar fashion, right? If you have a sub here instead of add, it'll still work in a similar fashion. So there you go. That's how you create a very simple hook with simple custom hook. In the next video, we're going to be creating a little bit more complicated hook, which will involve useEffect as well. So yeah, that's pretty much it for this one. I'm going to see you in the next video. Hey everyone, welcome back. And in this video, let's just go ahead and take a look at how you can create more hooks in React. Now, before we do that, I want to shift this to a custom file. Let's say hooks.js, right? Just to keep things organized. And I also want to tell you about a single thing. And that thing is that every single one of these hooks, whenever you create them, are independent from each other's instance, right? So that means you can create these two hooks. I can import useCounter from hooks, right? And you can create two hooks right here from 150, like counter 2, add 2, something like that, right? And you can do this and they would be completely independent, right? They would not share any state or anything like that. So once you do that, once you refresh counter 2, once you refresh, you're going to be seeing, hopefully, well, looks like we have some problems. So let's check out in the console. useState is not defined, of course. Let's go to the hooks file and import useState from React, right? So once we do that, you're going to see that it should work now. So I can click on this and I can click on this. You can see their states are independent, right? So that is important thing. Next up is, let's just go ahead and try to implement a little bit more complicated hook. And this one will be a local storage hook in which I would want your hook to store whatever value you are writing, just like how useState works. We're going to be extending that to local storage. So I'm going to say this hook is use local storage, and then we're going to initialize it with a key name, which is of course the key of the local storage where you want to store it, and the initial value if you want, right? And this is going to create our effect of stateful component. Now, first things first, we do need a state and set state. We still need a state, and I'm going to initialize that with our initial value, right? And I'm also going to return the getters and setters like this. So, right now it pretty much is just a useState replica, right? But things get interesting when, actually, let's just go ahead and, use this. So I'm going to say input type text value. You're going to have, let's say, name and set name as use local storage. I'm going to say username as the key, and default value is Mehul, right? So I give it a value and I say on change, I want to set the value, set name to e.target.value, which is the current value from the input field, right? And I can also say name currently is name, right? So what we are doing here is that now whenever I type something here, you will see that it reflects on the screen, which is pretty cool. But what we also want to do is, as we are typing over here, this should also store the result in local storage so that when I refresh the page, we do not lose the existing thing, right? So how do we do that? Well, for that, first things first is that we have to observe whenever our state changes. And the way we can do it is using the useEffect hook, right? So this function fires whenever the state changes. And who changes the state? Well, the application, right? Because you set the name in the application on every keystroke. So whenever you change the state, this function right here inside the hook gets called. And inside this function, what we'll do is we'll say local storage.set item key and the state value, right? Now remember, the useState function fires after the update has been done. That is, after the state value has been updated, so we get a fresh value here, right? So we don't really have to worry about getting a stale value here. This will be a fresh value, and you can just go ahead and convert this to string if you want. Otherwise, this will automatically be done anyway. But yeah, so once you do that, it is now storing everything inside of local storage. So let's just go ahead and open this inside the browser. Let's see why we probably have some error. useEffect is not defined. Why not? And there we go. So once we do that, you can now see if I go to, let's say, application, local storage right here, you can see we have the username value and set to Mehul. And now let's just go ahead and start changing it. I'm going to say this is a pretty sweet hook, right? So you can see that as I was typing, this value was getting updated over and over, right? So now if I remove this and if I type, you can see it synchronously writes it to local storage. This is pretty cool, but if I refresh this, you can see that the hook value is lost. And why is that? Well, you see that, of course, this runs the moment this component is mounted, right? Because it's a hook, and the useEffect runs after the component is mounted. So we set it again to the default state which we had. So instead of this, what we can do is we can pretty much pass in a function here and try to compute the correct initial value. So the way we will do it is we'll do something like this. I'm going to say, let's say local storage value is local storage dot get item key, right? I'm going to say if we do have a local storage value, I'm going to return that. Otherwise, we just return the initial value, right? So that's how we can compute for a particular value inside of the initializer of the useState. There's one missing component here, and that is that inside useEffect you can see we are using both key and state, but the key is missing, right? So this means that if suddenly somehow, let's say this key is also a state variable which comes dynamically, we will overwrite over the wrong key, right? So in order to fix that, I want this effect to run again with the updated value once the key is also changed, right? In most of the cases, if you're using this, probably key will not change, but of course and obviously you have to write every single dependency which can change inside the dependency array. Alright, so now once we have done this, I guess that is pretty much it. But yeah, that's pretty much it about the overall picture. Now what you can do is go ahead and make use of this hook. At least we have a basic setup ready here. And you can say, for example, let's say if I do a Mehul hello world here and refresh this page, you're going to see that we still get the correct result stored directly in the browser input windows, right? Pretty cool stuff. You can do this with, let's say, email. email, set email, something like that. And you can say instead of username, you can say something like, and you're gonna have a little bit of mismatches because we have two web pages open there. So you can say email and mehul@codedown.com, right? And similarly, we can have the column for email, which is gonna be email, and this is gonna be email, and there we go. So now we can have, once I refresh this and enter Mehul Mohan, mehul@codedown.com, and once we refresh this, we're gonna see that both the values persist thanks to local storage hook, which we have created on our own. So yeah, that's pretty much it for this video. I hope you learned something new, something interesting. That will be all. And in the next video, we're going to be exploring something different.